Okay, so the second part of our session is all around digital transformation and really focusing on the transition from single solutions to a sort of broader ecosystem of solutions, building on top of the Autodesk platform, but also looking at how technology can be combined to provide you guys with a great workflow that works for your organization. So we'll dive first into a session with Tom Rudge on Oculo, which is built on top of the ACC platform. Then I'll do a small piece on digital twins, looking at how we can combine some of the technology stack you've got at the moment and use Autodesk Construction Cloud to facilitate the creation and management of digital twins on an ongoing basis. And then we'll hand over to Steve and Lawrence, who will look at our Navigate product, which is built on top of both Civil 3D and in this case Revit, and looks at making those solutions more effective and efficient, sort of reducing the time it takes to get what you need from those products. So without further ado, I will hand over to Tom Rudge, who will give us a presentation on Oculo.
Thank you very much for that, Rich. So yes, I will start from here. So hi all, my name is Tom Rudge and I will be walking you through today a presentation on the future of digital project delivery. So the first place to start is I'm going to run through some of the industry challenges that we face currently. One of the challenges we face currently is skill and labour shortage on our construction sites. We also have the likes of cultural change barriers, bringing in new people into our industry and getting them to see what we're doing and how we're working efficiently. Slow adoption of new technology and ways of working, and also inadequate communication, poor planning and budgeting, with still a large focus around using 2D drawings and information. So what I've got here is just showing you two graphs and trend lines. So on the left-hand side shows productivity. The red dashed line is construction productivity and the solid black line is other industries such as manufacturing. And as you can see, there's actually a decline there over the years. And on the right-hand side, it's to do with the cost of new construction projects, including the likes of materials, compared to other industries. So you can see straight away the challenge that we're facing currently. And with productivity going the way it is and the cost of new materials and products, etc., going up, we're needing to be more efficient with definitely the way we deliver projects across the construction industry. So what I'm going to show you is a case study today, and this case study is based on the University of Worcester and it's the Elizabeth Garett Anderson Building, which I'm going to run through and show you how this was delivered utilising technology. So to start with, the university had a vision. They started with this project here. So this is what it was like before. So it was a derelict building, not being occupied for a number of years. And they wanted to move that and create what you can see here as the sort of after vision. This is what they wanted based on what they were working with. But the question was, how could the university take a building like that and convert it into their finished product? This is where, with a combination of the university's vision and wanting to push technology, the main contractor, and also Symetri pulling together and using technology in a way to help be more efficient. So the first challenge we had was trying to capture what was currently there. So what I'm showing you now is a point cloud scan of that existing structure. So going around capturing this and pulling this into Autodesk Navisworks allowed us to see what was currently there. The reason why we needed to do this is because we needed accurate measurements to bring that into a design environment so we could actually build on that existing structure. When you look at how that was done currently, using 2D drawings and information to pull that together in photographs, it was a messy process, but using the likes of point clouds that I showed here, it was a key point of the success of the project, and especially from a sustainability point of view, using that existing structure that was already there, as you can see here, it allowed the university to use what was there, save costs and lights of demolition and move forward. So once we had the point cloud, the next step was we brought the point cloud into Autodesk Revit, which allowed us to link that directly into the design to make sure the new build of the project aligned with what was already there. And that is the result, as you can see here, being able to accurately measure that and bring it into one environment to make sure that what was being designed fit with the drawings and also the structures I mentioned that was existing. So this is what we ended up with. So we ended up with the existing structure, as you can see there, and on the left-hand side, you can see the SFS, and that was the new build. So it worked in terms of the process using technologies such as the point cloud, Autodesk Navisworks, and Autodesk Revit, bringing that all together created this outcome. But a problem we tend to face on projects is being able to prove what was installed at points in time. And the traditional way to do this was to go around, take thousands of photographs and prove that what was being installed suited the as-built representation. So what we decided to do on this project was to introduce a new solution, which is called Oculo. So what exactly is Oculo? So Oculo is all around 3 simple steps. It is around capturing your information using 360-degree cameras. That could be either mounted on top of a hard hat or using a selfie stick, simply walking around the site, and using artificial intelligence, Oculo maps the way you walk around the site on top of a 2D floor plan. So it knows exactly where you are, and it removes the need of using the likes of GPS to track as you're walking around the building. So that's the power of now using artificial intelligence and bringing this into our building workflows. And finally, 360 coverage. So the key bit about this solution is that it's very easy to understand and easy to pick up. What I'm going to do now is I'm going to dive in and show you the result of using this on the Elizabeth Garett Anderson Building. And whilst to do this, if you've ever used Google Maps Street View before, just think of the functionality used in that and see how similar it is to using it on this project. So to start with, you can see these yellow blobs, and at the top you've got a date. So effectively, the date represents the date that someone has walked around to undertake the scan, and the yellow blobs are the site route that someone has taken to walk around the project and capture the latest progress on site. If you go to floor and go to ground floor here, the best way is to go to external. That now, using a 360-degree photograph from the camera, shows you the power that it gave us on the project on proving what was installed at that point in time. So not only is this for internal, but also externally we could use this. But I think the power comes now, going to the mini-map and going on the internal side of the building. This is where you get the true benefit of a solution like this. And as you can see, just from standing in that point in time and being able to view around that location, you've got the power now to be able to do this, which is a comparison mode, to compare 2 points together at that exact point you were standing to see the progress that has been made over that amount of time. Here you can go back in date. So if you go to now the 25th of March 2022 comparing to the 26th of January 2023, you can see the power of going from an existing structure to where you were at that point in time. With this being based on Autodesk Forge, models can be brought into this environment so you can in sync compare the latest scan data to the latest model as shown here. So with this being a model 2, the key bit is that you can click on any element you wish, go to properties, and it's going to give you all of the model properties in this environment. So not only did this benefit the main contractor by using this through the construction phase, but also it benefited the university at the end of the project for facilities management and maintenance purposes. Key tool that I just want to bring up that the solution encompasses is the ability to create issues in the platform. And I've listed there that the key thing is that it directly links to Autodesk BIM 360 and Autodesk Construction Cloud. So the ability to raise issues not only in the platform but also linking to these systems means that as you're using the likes of Autodesk Construction Cloud as your common data environment, then issues created automatically get pushed through into your common data environment, stored, and the information assigned against that particular issue. So if you wish to create the likes of a report directly from Oculo, then you've got that track record of who created the issue, who the issue was assigned to, and also any key information such as the description behind that issue on why it was created. And this was the end result. So this now is some professional photos taken at the end of the project, and hopefully you can see the power of using the Oculo system to work towards this result here. So Oculo didn't only just work in terms of benefit in terms of the workflows and how we traditionally did it, but getting towards that end result and that working towards the vision, that it allowed us to go on that journey and work towards this end result. So how exactly has Oculo helped others then? So I'll give you an example of how Symetri have used it on a project. But what benefit has this brought to others? So I'm going back to this slide now. So going back to industry challenges. So relating to labour shortages and also skill shortage, the key bit which you've hopefully picked up from this is that with it being able to take a 360-degree camera out onto site, capture the progress there, you're able to just have one person do this rather than multiple people need to go out and take thousands of photographs. So straight away, you're being more efficient with your workforce. Relating now to the cultural gap and also slow adoption of technology, with this having very similar functionality to Google Maps Street View, it takes no time at all to get trained up and to be immersed in the platform and basically be able to pick this up and run with it on your project. So that was a key bit to cover them items there. And finally, to do with budgeting and planning. So of course, with Oculo, you're able to have this across multiple sites. That's the idea of this solution. And by be able to go to that project and see the progress made over certain points in time, over time, by using a solution like this, you'll be able to go back to that project and see what took you the most time and where you lost the most time. So as you start capturing this data, you will inevitably become more efficient as you go along in your projects. So just some examples here, case studies that others have used. So Wilmot Dixon saw a lower cost of rework by 5%. Skanska saw a lower cost of claims, a reduction of 10% there. HB Revis, faster issue resolution, linking back to before about connection to Autodesk Construction Cloud and Autodesk BIM 360, with being able to raise issues instantly and assign them to relevant people in the system. And finally, Purcell, with time savings, a reduction of time, not needing to travel to site because, again, everything is on an online solution and can be seen from the likes of a laptop with internet connection. And a key bit here, especially for Symetri, was this here in regards to time savings with the documentation process. So traditionally, as I mentioned, taking thousands of photographs can take anywhere between 5 to 6 hours, depending on site size, of course, to capture the physical state out on site. With Oculo, it gives you the power to improve this by 10 times the amount. And that might seem like a crazy number, but that is true in representation of that traditional process. So again, just from improving this side of it will make you more efficient and ultimately improve productivity on construction sites, which is what we need to aim for moving forward now. And linking back now, final slide just on sustainability. With the ability to capture your projects, it will reduce the carbon footprint. So you will be more eco-friendly, being able to again, capture your projects, reduce the need for the likes of your planners or construction directors to go around and check progress on site. It's all there and they can view that whenever they wish. And that was a big point to using that on the Elizabeth Garett Anderson case study. So now that's a summary for what I wanted to run through today, but hopefully you see just one solution out of the hundreds that I showed you at the start of this presentation can have an impact regarding to a particular project. And in this project it was the Elizabeth Garett Anderson Building. But with the future now looking towards the likes of artificial intelligence, I think there's so much more potential for us to improve and to get that productivity up to we're working more efficiently and utilising our labour and skill more efficiently.